Hi all, my name is Omer Saritac. I am a PhD student at London Business School, and this is a joint work with my advisor Aouad and Chiwei. In this work, we study how the control platforms have over prices affect social welfare. So there are many platforms that tightly control pricing. For example, large ride-hailing platforms often don't let drivers have any say in how the prices are set. And this high level of control caused concerns that these platforms exercise too much control, that this high level of control undermines the basic premise of the gig economy, which is flexibility. There are companies that responded to this concern. Bolt is one of them. They're the biggest competitor to Uber in Europe. They let drivers set their own prices in many major cities in Europe. In fact, I had the opportunity to work there this summer, trying to better understand and improve their decentralized pricing product. There are also newly emerging ride-hailing companies like Empower that give full power to drivers in setting their prices. So one natural question is, why do they do this? Why do they let their drivers set their own prices? So there are two main reasons, to the best of my knowledge. One reason is that giving drivers more flexibility may help platforms attract new drivers and gain market share. Now, another reason is there's legal pressure towards gig economy companies to give their workers more autonomy. So I'm not going to go into the details of the legal issues here, but uh, as a result of a bill called AB5 bill that was put in motion in California in 2020, Uber started to experiment with a decentralized pricing scheme. According to this pricing scheme, Uber would set a base price, the driver would set a multiplier, and the multiplication of these two would make up the final price. However, after Uber and Lyft funded a major campaign to override AB5, they became exempt from the law. About a year and a few months after the introduction of the bill, Uber rolled back its decentralized pricing product, saying that it led to a degradation of rider experience and rider cancellations increased significantly. So 80% of riders were canceling when the multiplier was more than 1x. So riders were being strategic and canceling relatively higher prices. And this was decreasing match efficiency. It was making the market more difficult to clear. So there's a sort of divide in the industry in terms of the level of control platforms exert on pricing. So on the one hand, we have companies like Bolt and Empower. We could perhaps add accommodation platforms like Airbnb to this group that are decentralizing their pricing decisions. On the other hand, we have companies like Uber and Lyft that tightly control pricing. So in this work, we want to offer a way to compare these two modes of pricing. To make this comparison, we need to understand the trade-offs that come with more decentralization, more flexibility to suppliers or workers. So on the one hand, when agents make decisions to maximize their own utilities, they may not consider the negative effects, negative externalities of their decisions to the overall welfare. So one important consequence of this is with increased range of prices in the market, as in the Uber example that I just mentioned, customers may want to search for better options for longer, and this can make it more difficult to clear the market. So on the other hand, with more flexibility, agents in the market can use private information that they have, and the platform may not have access to. This may remind some listeners seminal works of Friedrich Hayek, by the way. For example, so going back to our case, suppliers in the market can set prices that are adapted to their cost structures. This can lead to a market that mimics price discrimination. And with price discrimination, now customers with relatively lower willingness to pay can benefit from the service. This can also lead to more supplier participation simply because they can choose higher prices now. So understanding this trade-off by conducting experiments is often costly for platforms. So we take a modeling approach. We introduce a pricing and matching model with strategic and heterogeneous agents. Our main contribution is to characterize the equilibrium. This is important because it allows us to compare market outcomes from centralized and decentralized markets. And the summary of what we find is first, supply demand balance in the market is crucial to determine whether decentralization can be beneficial for welfare. This is because the platform can make pricing decisions to balance supply and demand, but agents may not want to or be able to do that. Second, we find that the level of market patience, we can think of this as the willingness to search for customers or willingness to wait in the market, is very important in this comparison. So to make this comparison, we need a way to model the level of control in pricing, and we want to keep it in line with the industry practice while modeling it. We opt for the following way. We say that the platform chooses a menu of prices and offers it to suppliers. This is similar to Uber's or Bolt's approach. If this menu consists of a single price, we call the platform centralized. If the menu is not restrictive at all, we call it decentralized. And for anything in between, we call the platform semi-centralized, although I'm not going to talk about semi-centralized today for time for the time constraint. So we have a continuum of strategic and heterogeneous customers and suppliers. Customers have heterogeneous valuations and suppliers have heterogeneous costs. These are their types. Their strategies are suppliers set prices and buyers decide to accept or reject matches. So this is a discrete time model. In the beginning of each round, we have fluid arrivals of uniform density over agent types. Density of arrivals for each type is lambda S for suppliers and lambda C for customers. After arrivals, agents of both sides decide to enter the market if and only if their expected utility from entering is positive. Agents who enter are matched uniformly randomly. This way of matching is common in the literature. We mean to model the search process by matching. So, for example, a customer may not find the lowest price at first try. They may need to search for that. We use this random matching process to model it. And given the offered matches, buyers decide to accept or reject the matches based on their utilities. Their utility is valuation minus price plus a zero mean random shock. So if the price is sufficiently high or random shock is sufficiently negative, then they will want to reject. The suppliers get the profit price minus cost. So matched agents leave the market. Out of remaining agents, at the end of the period, each individual customer and supplier leave the market with probabilities mu C and mu S. So these processes are repeated in each time period, and we analyze the steady state of the market. Okay, so to analyze a steady state, we use a notion of stationary equilibrium. This is basically the mean field equilibrium, and it's often been used before. According to this, suppliers pick prices to maximize their long-term expected profit. Customers set thresholds. We can show that threshold policy is optimal for customers. They set thresholds to maximize their long-term expected surplus. All right. So before I move on the results, I will very briefly talk about related literature. There are many excellent related works. Unfortunately, I'll be brief due to time constraint. I should first say that our model is inspired by the very nice work of Kanoria and Saban. In terms of positioning of our work, most of these works do not compare centralized and decentralized pricing controls. One exception to this is the work by Kashan Desideraire and Sucralist, but their focus and modeling approach are quite different. They focus on optimal payment schemes for suppliers, and they do not consider a dynamic market. So the search friction, which is I would say foundational in our model, does not exist in their model. Okay, so our goal is to make a comparison of equilibria that arise from centralized and decentralized platforms. The model we have is a complicated one. We have heterogeneous and strategic agents. So characterizing equilibria is not straightforward and often not possible in these systems. Arguably, this is why prior works may have studied simpler models. So our first result to make this comparison possible or easier is that we prove the uniqueness of equilibrium for the centralized and decentralized platforms. So the comparison is going to be clean. This result makes sure that we only need to compare one equilibrium for each type agent. But more importantly, our main theoretical result is that we find a piecewise polynomial system that characterizes all stationary equilibria. So although this polynomial system does not yield a closed form solution, we can numerically solve it quite easily. It's not computationally expensive. This is very important because this is what makes the comparison possible. So given the equilibrium characterization, we produce plots that describe the welfare comparison for various market conditions. So we start with comparing the decentralized platform with welfare maximizing platform. We can think of this platform as playing the long game and aiming higher customer and supplier satisfaction to perhaps gain higher market share. So we look at different market conditions defined by, on the y-axis, arrival rate ratios, and on the x-axis, departure rates. I should stress that the arrival ratio is about arrivals. It's about the inflow of agents at the beginning of each round, and it does not directly translate into the number of agents at equilibrium because of entry decisions and matching. So on the x-axis, we have departure rates model willingness to wait or search for agents. We use the performance metric welfare ratio defined by welfare of the decentralized platform divided by that of the centralized platform. So higher welfare ratio means relatively better performance by the decentralized platform. So greener color code means decentralization is better, basically. Okay, so the first thing to note about this plot is that the welfare ratio is always smaller than 1. Therefore, the altruistic centralized platform always perform better than the decentralized platform in terms of welfare. And this result is quite general for various arrival distributions when we relax the uniformity assumption for the arrival distributions by simulation. But I should note that we recently realized that we can actually construct cases where the welfare ratio is larger than 1. So another pattern we notice is that the decentralization performs relatively better as the market is more balanced in terms of number of supply and demand in the market. This 0.5 here is actually where the number of supply, the 0.5 on the y-axis here, is actually where the number of supply and demand are equal to each other due to entry conditions. So why is it that supply-demand balance is important? So the reason is that the prices picked by the centralized platform balance supply and demand and increase throughput, but the supplier's profit maximizing prices don't achieve this balance especially when arrival ratio is too large or too small. So lastly, we observe that as agents become more patient, as they're willing to wait or search more, decentralization converges to first best. The way I make sense of this result, I should say, is agents compete with future versions of themselves. As agents become more patient, this competition becomes more intense, and this leads to increased efficiency. Perhaps this can partly explain why in accommodation platforms like Airbnb, the prices are set by suppliers in the market. They're decentralized. In such markets, the time scale is much larger, and the customers go through many options before deciding on their final choices. So we could explain this by them having a market with patient agents. Okay, so far we looked at the case where the platform is altruistic and maximizes welfare. However, platforms are typically not completely altruistic. So then the natural question is, how does the comparison look like when the platform is profit maximizing? We see similar patterns in the as in the altruistic platform case, except that in this region showed by these arrows, where agents are more patient and we have relatively low demand, decentralization can achieve higher social welfare than decentralized platforms. Why is that? I'm not going to show you the plots due to limited time, but what we find is that when the demand is sufficiently low, the supply-demand balancing price is too low for the platform to maximize its profits. The platform increases the prices to levels where supply and demand are not balanced, and this hurts the welfare in the market. Okay. So we do not only plot the results, we can also theoretically argue that our main results from numerical experiments hold. First, we look at the impatient market. It's the rightmost column in this plot. We prove that the worst case welfare ratio is 1/4 against the welfare maximal price and 1/2 against profit maximal price. However, as the agents become more patient, the decentralized outcome converges to the socially optimal outcome. I think what's more interesting is that the price dispersion decreases and all prices converge to supply-demand balancing price. I think this reinforces the idea that supply-demand balance is important for market efficiency in the setting. Okay, so there's also a connection between this result and the famous cost conjecture. When departure rates, mu C and mu S, get very low, it's like saying they value future benefits almost as much as today's. So discount rates go to 1. Cost conjecture basically says that a monopoly seller over time will have to lower their price because basically customers can hold out. Therefore, the monopolist's market power disappears and the profits are cut to 0. Now, our theorem kind of supports this idea, but for markets with competing buyers and sellers, the key difference is that, in my view, this is the most interesting part of this result. In our case, the prices converge to the market clearing price, and most sellers still make profit. Okay, to sum up, we find that decentralization creates matching frictions. So Uber's concern that decentralization decreased matching efficiency is partially valid according to our model. However, decentralization may be beneficial when platform is not altruistic and in time-insensitive markets where suppliers can remain available for longer and customers are willing to search for longer. So the concern about high level of control of platforms is valid depending on their objective function. I think this indicates that transparency of pricing algorithms are important for regulators. Thanks for listening.